Alrighty, guys. Step one, please. Look up here. I want you to trace this left. That represents the orange slice. Trace it around, like so. And then this smaller one represents the tangerine. Technically it's a clementine. Yes, I stand corrected. Put this down here, 360 degrees, 360 degrees. Michael, guys, I need this little running conversation here to stop. I need you to focus, stay right on task with me, okay? Now, I'd like you to write in the middle, 360 equals 360, please. Put that in the middle there. 360 equals 360. That seems simplistic, but I'm going to make a real simple point here in just a second. I said this conversation needs to stop. Listen, thank you. Now what I'd like you to do is I'd like you to trace on the inside here. Trace on the inside. Notice I switched colors. You can dot that if you like. I'd like you to put a C there for circumference. You might want to dot that if you wish to distinguish it. If you have bold, that'd be great. Now sweep around this inside. Use a dot if you don't have different colors. Put C for that. Alrighty, simple question. Answer this in your groups. The circumference on the left to the circumference on the right, same or different?
Same. It's the same. Different. 360 equal of the.
Okay, listen carefully to what I have to say. Okay, how many of you think it's the same? Okay, how many think it's different? Okay, you have 10 seconds to argue who's right in your teams. Go. Same or different? Circumference. Okay, ready? Look up here, guys. Look up here. The degrees are the same. So those of you who are saying the same, if you were referring to the degrees, you are correct. However, the length around this circle is of difference to the length around this circle. We're going to be coming back to that. Look very closely. We're going to talk about what's the difference between measure, which is degrees, versus length, which is part of the circumference. Let's start with something simple. Okay, I'd like you to take those orange slices, someone on your team be in charge of this, and you are going to slice a 90-degree wedge, one out of the orange and one out of the tangerine. 90 degree, a quarter slice. Only one. Slice a quarter slice out, please. A quarter slice.
Someone get it.
Okay, quarter slice like so. Do not slice the whole thing in quarters. Quarter slice. At one out of each. Yes. One out of each. Quarter slice. I would like that half in the round. Thank you. Yes, she came back. Go. All right. Now, I'd like you to draw, students, what you see. We're going to draw what we see. We have a 3/4 slice. There's a right angle. 3/4 slice. So you have two orange slices that look like Pac-Man. Okay. And then you have a quarter orange slice and a quarter tangerine slice. So please draw those. Those of you who are slicing and dicing, I need you to draw that as well. Yes, ma'am. David? Not in this spot. Not right now.
Thank you.
Okay, now what I'd like you to do is label on the paper, please, this wedge, O-R-A, that's wedge O-R-A. This, yes it is, this wedge is going to be L-E-M.
What was it? LFM?
L-E-M. Oh, Russell, I see what you did, Russell. Okay. All right, now, I'd like you to shade, please. Shade this and shade that. For both of these, what you just shaded was called a sector area. Sector area. A sector area is just a wedge of the area. Think of it as a pizza slice. This is a part of the notes, so this is a good review because you're supposed to start memorizing this stuff. Last night was first exposure. Okay, now it's repeat. So we know to get a sector, it's simply a fraction. Nice job. Fraction, out loud, who knows the next blank? Of the? Area. Yes, it is a piece of the area. This is called sector area. It's a piece of the area. Take a look here. We're going to build our equation. To get a fraction is a part over a whole. It's a part over a whole. Exactly. Yes, yes. This is a pie slice one. Okie dokie. So, part over whole times the whole area. It's a fraction of. Of means two. Does not mean equals. Part over whole, that's fraction, of area. This will help you remember it because you have to memorize these equations. Our part is going to be whatever the central angle is. We're going to call that theta. Greek letter. Over the whole, which is 360, of course. Part over whole. Times area of a circle, which is pi r squared. Now, put parentheses around the r, please. It's really, really important when you work with this equation that you only square the radius. Only square the radius. The most common mistake students make in their calculators is they'll do that degree times pi times the radius, and then they square everything on the top. To avoid that mistake, what I like to do is I like to work right to left. I start with the radius, I square it, then I times by pi, times by theta, divide by 360. I like to work right to left. That'll keep you from getting confused there. Yes? Theta. Theta is the central angle here. Whatever. Theta is used for angles. It's like X for letters. Okay, we'll do an example together and I'll show you exactly what theta is going to be, okay? For now, just memorize this equation. All right? Okay, now we're going to skip a little bit. Go on to the next page, please. This is sector area. Okay, sing with me. Measure of a central angle to its arc the same. You missed out, guys. So same. Measure of a central angle to its arc the same. Now I want you to draw just those wedges that you have on your plate. You have a larger orange wedge and a smaller tangerine wedge. Alrighty, guys. So here's your wedges. They're both 90 degrees. Okay, so we can go like this, right? The measure of OA, the arc, is 90. Because measure of a central angle to its arc the same. And the measure of LM, the arc, is also 90 degrees. Put those measures on there, please. Thank you. All right, ready to slice and dice again? Okay, watch up here. This is, if you hold the orange up, I'd like you to slice the pulp away from the peel of both your wedges. The pulp away from the peel. You're going to end up with like 2 eyebrows. Pulp away from the peel. The tangerine, you could probably just peel it apart. I'll show you my plate in just a second. You should end up with 2 eyebrows. Pulp away from the peel. Pulp away from the peel. Pulp away from the peel. No, we're doing it. Got it? 2 eyebrows? Okay. Peel that. Cut it.
Some people are into that.
Pulp away from the peel. Should end up with 2 eyebrows. Yeah, it's not easy. You know, if you slice right along the tip. Okay, now come down here, guys. Those of you not slicing, you're going to draw. You now have 2 eyebrows. Looks like so. You have a 1 peel, a larger peel, and then a smaller peel. They're both curved. This was the OA peel, and this was the LM peel. So you can see they're just pulled apart from the wedges. Both of them have a 90-degree curve to it. Write that down, please. We're almost done. I promised we'd be done by the 55. Stay right with me. Okay, I'd like you to circle this little M here and write the word measure of. Measure of. Watch the term. In the next 1 minute, you're going to hear these 2 words, measure and length. They are not the same thing. In fact, the last thing you're going to do as we wrap this up, is you're going to explain what is the difference between measure and length. When we say measure of the arc, it refers to the degrees. Draw a little arrow to that little degree sign. So, in this case, the measure is equal. They both measure 90 degrees. All right, now, last thing I'd like you to do, please, is take those 2 peels or 2 eyebrows, and I want you to flatten them sticky side down, flatten them on your plate right next to each other. Push them down, kind of make them stick. I want you to flatten them directly on your plate, sticky side down. Flatten them on your plate. Push them down and put them right next to each other. Flatten them. I'd like you to flatten your 2 peels right next to each other. Flatten them. I'd like you to flatten the peels right next to each other. Flatten the peels right next to each other. Make sure the entire team can see this. I need you to flatten the peels sticky side down, right next to each other. Flatten the peels, please. Flatten the peels. Okay. I need that special one around there. Away. Alrighty, guys. Now, real simple. Take your peels. Now look at them. The length of the peels, same or different? Different. Aha. Aha. That's really important. Watch here. This is the whole lesson right here. Draw your larger, you have a larger orange peel that's flat. And your clementine peel should be a little bit smaller. This one was OA. This one was LM. I'd like you to write the word length. Write the word length right along those. That represents your flattened peels. The flattened peels. Okay, you guys just said the lengths are different. Here's your summary, guys. As a team, I'd like you to summarize this. And this is part of your sign-off today. So as a team, discuss this until you can write something down. I'll tell you. Look up here. Here, the measures are the same. Here, the lengths are different. Please explain in a single sentence how is it that the arc measures can be the same, but the arc lengths can be different. Define what is the difference between arc measure and arc length. So, write it down. As a team, talk about it and write it. Talk about it and write it out. Talk about it, write it out. Talk about it, write it out. Talk about it, write it out. Jordan, I have the wrong one, dear. Maybe you mixed them up. That's the previous one. It's okay. You're not the first person to have done that. Yes, ma'am. The one before? That's good. That'd be great. Students, elect someone in your team to be a reader, please. A reader for that sentence. A reader. Michael, can you hand that to me, please? Oh. Bones, come on. Alrighty, guys, pay attention. 5. I'm going to ask 3 teams to read their definition. 3 teams. Front, middle team, read me your definition. Go. You're not done yet? Okay, come over here. This team, Jen and Company, read me your sentence. That team over there. I know, Jenna. I told you guys, I told you to write a sentence. Okay, you have another 30 seconds. Write a sentence. Okay, Ms. Streeter, go ahead. Say it out loud. Measure is the degree of the arc. Length is how long the arc is. So measure has to do with degrees, and length has to do with long of the arc. Okay. More clarification. Give me another one. Length is a concept that can be flattened. That's important. That means we can use things like centimeters, meters, and inches for arc length. Mr. Garrido, take a shot. Was it you guys back there who said you want to try it? Go for it. No, you're it. Go.
Arc measure is angle length is now.
Okay, so length is a matter of a piece of the circumference. That's kind of what I was fishing for. Length is a piece of the circumference, whereas measure is curvature of the arc. This is our last equation, then we'll take a quick break, do one example, and then we're done. So underline the word arc length. Go to the right side of that paper. Arc length, right there, that orange peel. When it says length, write the word peel underneath. That'll help jog your memory. We're talking about the peel there. Is a fraction of circumference. Fraction of circumference. The other was fraction of area. This is fraction of circumference. So how do you get that? Again, it's part over the whole. Part over the whole. Times, this time, times the circle's circumference. So just put a capital C there. Not area. Okay, not area. It's a piece of the circumference. So, final equation here is that theta over 360. This time it is d pi. That is sector area. All right, you have two equations, guys. I want you to take about 1 minute and attempt to memorize these because I'm going to test you on them. Your two equations are this. You might want to circle these or highlight them. These two equations, I'm going to highlight them nice and bright for you. Sector area was on page 2. Sector area on page 2. On page 4, this should read arc length. That's actually a typo. You need to fix it. Arc length. Arc length. Sector area, arc length. Ready? Quiz each other. You have a minute to memorize those two equations. Go. Sector area, arc length. I'll tell you in a second. Okay, guys, as of now, you may dispose of the fruit. Please, all I ask is that you save the knife. Otherwise, walk the plate back. All right, guys, save up. See a knife back here, guys. If you choose to. I'm going to do one example problem with you. On the rapid fire, turn to the rapid fire page. I'm going to do a portion of this with you. Go to the rapid fire page, please. Get out a calculator. Get out a calculator. I'm going to do part of the rapid fire with you, please. Yes, ma'am. No calculator, but there's a calculator that doesn't have the. Okay, oh, you know what? I should have taken out the no calculator. Yes, you may have a calculator here. Sorry for the confusion. All right, we're going to do number 2. When I get you guys time on your own, you need to backtrack and do number 1. So, number 1, you will do and check. Number 2, I'm going to do with you. Take a look up here. We'll do this one together. Okay, it says you can do this with or without pi. Let me show you what I mean by that. Step number 1, I'd like you to trace P, A, Q, and sweep. This team, stop. Again, follow. Thank you. All right, Whitney, what's the measure of that angle, ma'am?
150.
Thank you, 150. Pay attention, I'm going to be calling on people, so do not say answers out loud. Listen for your name. Now, I'd like you to trace arc PQ, please. Trace arc PQ. Arc PQ, trace it. Cody B, what's the measure of PQ? Measure. Measure. Yes, because measure of a central angle. So put 150 degrees. Remember, measure has to deal with degrees there. Patrick, what is the radius, sir? What is the radius, sir? Thank you. Trace the diameter, please. Everybody, trace the diameter. Trace the diameter.
I know what the diameter is.
Fine, go for it, Cody.
36.
Yes, 36. It's double. Okay, now we're ready to work here. Now we're ready to work. Step 1, it says right here, find the sector area from memory. Write out just the equation of sector area. Go from memory. I'll show you the answer in about 20 seconds. From memory. Just for now, just write the equation, please. It is theta, yes. Should only take you a couple seconds to write that down. Okay, take a look up here. Theta over 360 times pi r squared. Now we're going to circle, plug, chug. Ready? Our theta, circle, 150 150. Here is pi. I bring down pi. My radius, 18. Now watch the magic here. Some of these you can actually do without a calculator. I'm going to do this with what's called pi form first. Cancel the zeros. 3 goes, squared, yes. Okay, got it. 3 goes in here 5 times. 3 goes in here 12 times. Okay, and then I'm going to do 18 squared.
Where'd 5 go in there, Lauren?
Yeah, I know, but 5 doesn't go in the bottom. I'm trying to reduce it. It's 324. So I'm going to have 5 over 12 times 324 pi. Okay, I just switched these so I don't confuse the pi there. Now I'm going to do 324 divided by 12. I get 27 times 5. Get 135. So my answer here is actually 135 pi units squared. That's called pi form. You kind of calculate it, ignoring pi, you just tack it back on.
How do you get it? You divide.
Okay, I went 12 goes in here 27 times. 5 times 27 is 135. Or you just multiply this times pi, and you get the non-pi form, which is 424.1. 0.1 units squared.
That's the or?
That's or. Yes, it is or.
Wait, 25, 25, what?
I went 135 times pi.
No.
Gets you this.
Do we have to write that? 27 times 5.
This is 135. You don't have to do pi form. I prefer pi form, but if that bothers you to have Greek letters on your answer, then multiply it out.
Pi is a Greek letter?
Pi is a Greek letter, yes. Okay, let's try this one over here. Ready? Now, write the equation for arc length. Again, try to do that from memory. Arc length, the fraction of the circumference. Write that from memory. Adam, how do you do arc length? Theta. Times d pi, which is circumference. It's a piece of the circumference. Our diameter here is 36. So we're going to come and bring it here. Our theta, again, is 150 times 36 pi. This one's actually really easy. What? Why 36? Diameter. 18 times 2. Okay? We're getting there. We're getting there. This goes in here 10 times. Now you go 10 goes into 150 15 times. So the answer is simply 15 pi units. Your units are singular here. I'll try it again. Take a look up here. I just canceled a bunch of stuff out. Here's the original. You guys okay with the original?
Yeah.
Okay, watch. 36 goes into 360 10 times. Did I lose you? Are we okay? Then 10 goes into 150 15 times. Okay? All right. Then we do 15 times pi. 15. That's fine, guys. There's a dozen ways to do this. 47.1. 47.1 units. Okay? That's a sample of each of them. What I'd like you guys to do is backtrack. Finish just problem 1. Should only take you a couple minutes. Check page 5. And then crank it away. Page 6, 7, and 8. You have a half an hour. Go. Lights, please. Lights. You're now finishing problem 1 on page 5. Finish problem 1 on page 5. It's a review. Thank you, Cody. Up. Thank you. All right. Finish problem 1.